Welcome student, welcome to online class subject maths number system. In the last class I explained the number system in that surds. Okay, so you know that a surd is an irrational root of a rational number. Irrational root of a rational number. I told you to write the 20 square numbers and also their square roots. Okay, the numbers, the perfect square numbers which are under the square root are not a surds. A surds means square root symbol with the non-perfect square number. See 3. This is a perfect square number. Now 4 is a perfect square number. This is not a perfect square, so this is a surd. Here 4 is a perfect square number. You can't take this inside the square root symbol like this. Then if you are take the 4 inside the square root symbol, then it is not a surd, because you will get a rational number. Square root of 4 is 2. That's why if you are taking cube inside this, order is 3, then it is a surd. Clear? So based on the orders and the numbers inside the square root symbol, we are classifying, or we are telling that whether the given is a surd or not. Also, you have studied the laws of surds and how to express a surd in an exponent form and exponent form into surds form. Then we have studied the fundamental operations on the surd. Okay, what are the fundamental operations? Addition, subtraction. So for adding or subtracting the surds, what is the condition? They should be same order and radicand also be same. If the radicands are not same, then what you can do is you should reduce the given surds into its simplest form. Okay, just I will show you one. See, square root of 18. This is not a reduced form, or it is not in the simplest form. Simplest form means what is there, the radicand, that cannot be further simplified. Okay, now this can be written as square root of 9 into 2. So converting a given surd into its simplest form means removing a perfect square number from inside to outside. So like this, then square root of 9 is 3, then 2 don't have square root, so you write on this as 3 root 2. This is a simplest form of this. Okay, and this is the standard form of this. So how to convert the standard form? Just put it the coefficient, numerical coefficient inside. After you are putting inside, what you can do is, already 2 is there, into what the number is there, you should write as it is and put the square. That means what is the order is there, you should write that. Then this is square root of 2 into 9, so square root of 18. So conversion of surd into its simplest form, right, or mixed form. Mixed form means the number numerical coefficient is other than 1. If the numerical coefficient is 1, then it is called as pure surd. It is called as pure surd, and this is the mixed surd. So mixed surd means a surd which is having a numerical coefficient other than 1. Clear? Then next is we used how to add or subtract or multiply the surds. In multiplication, the last class I explained how to multiply two surds of same order. So if the orders are same, how to multiply the surds? Just put it in a one square root symbol, and inside that you write down the radicand and multiply. So like this, square root of 2 into square root of 3. Now what is this? This is equal to square root of 2 3s are 6. So inside under one square root symbol you can multiply directly, then this is square root 6. This is multiplication of surds with the same order. Clear? Now next is if the orders are different, how to multiply the given surds. Now let us explain that. Look at carefully. Here square root of 3 into cube root of 2. Now here the two surd. In this surd order is 2 and in this surd order is 3. So we cannot multiply this directly because orders are different. Now in this case, how to multiply the surds? Here you can multiply these surds by making their orders equal. Okay. Now how to make the orders equal? For that you should take the LCM of the order. So first is 2 and another one is 3. Now both are prime number, so multiply together. 2 3s are 6. So order is 6. That means LCM of the orders is 6. Now look at the board how I am converting the order into the LCM. For this, look at square root of, now here is 3. In order to make it 6, then what you can do is multiply by 2. So what number you are multiplying the order, put the same number as the power of the radicand. Clear? Now into, here look at this, order is 3. Now look at, here is order is 2, then you should multiply by 3. So here is 3 cube. Now order is 3, you are multiplying with 2. So here is 2 square. Now this is what? 2 3s are 6. 3 cube is 27 into 6th root 4. Now look at this, orders are same. Therefore you can write it under one surd, 6th root 27 into 4. 7 4s are 28, 2. 4 2s are 8 plus 2 is 10. So 6th root of 108. Clear? This is multiplication of surds with a different order. Now I am explaining one more. Fourth root of 3 into cube root of 2. Fourth root of 3 into cube root of 2. Now what is the LCM of 3 and 4? So again here is one is prime and another one is non-prime. So their LCM is 12. 3 4s are 12. Just multiply together. Now converting the each order. Order is 4. So here is 4. You should multiply 4 with the 3. So into 3. Then it becomes 3 cube into, here is order is 3, then you should multiply with the 4, then here is 2 to the power of 4. Followed? Now here this is 4 3s are 12, 3 3s are 9, 9 3s are 27 into 4 12th root of 2 2s are 4, 4 2s are 8, 8 2s are 16. Okay, now under one square root symbol you should multiply 27 into 16. 27 into 16. So now how to multiply that I will show you. Now 27 into 16. Now take this one, I will multiply here. 27 into 16. 7 6 are 42, 4, 6 2 are 12, plus 4, 16. 7 1s are 7, 1 2 is 2. 2, 3, 1, 3, 1, 4. 432. Okay. So this is 12th root 432. Understood? Now I will show you one more. Clear this? So just look at the problems. How to do the multiplication with the different orders. Multiplication with the different orders. Now let us take one more. Fifth root of 2 into square root of 3. Fifth root of 2 into square root of 3. Now order is 2 and 5. So both are prime. So you should take the product as a LCM. Now convert each order into 10. So order is 5. So you should multiply by 2. So 10 square. 2 square into square root of 2. You should multiply by 5. So 3 to the power of 5. Now this is what? 10th root of 4 into 10th root of 3 to the power of 5. So you should multiply 3 5 times. 3 3 is 9, 3 3 is 9, 3. So 9 9 is 81. 81 into 3. It is 243. 243. Now under one third, it is a 10th root of 4 into 243. That is 10th root of 4 3 is 12. 1 4 4 is 16. 1 17. 1 4 2 is 8 plus 1 9. So this is the product of two surds with the different orders, radical, different radical. Clear? This is how to multiply the surds with a different radical or order. Now next is a simplification, and you know how to multiply the binomial surds using formula a plus b into a minus b and a plus b whole square also. Now let us take a plus b into a minus b. So square root of 8 minus square root of 2 into square root of 8 plus square root of 2. So here this can be written as a minus b into a plus b, that is equal to a square minus b square. So a means root 8 whole square and b is root 2 whole square. Then square root get cancelled. 8 minus 2, that is equal to 6. This is what? A plus b into a minus b formula. How to expand. Then one a plus b whole square formula, root 3 plus root 7 whole square is equal to root 3 whole square plus root 7 whole square plus 2 into root 3 into root 7. So square root get cancelled. This is 3 plus 7 plus 2 root 21, or this is 10 plus 2 root 21. Here this is what the product of two binomials using a plus b whole square formula or a plus b into a minus b is equal to a square minus b square formula. You can solve the surds. Now the next important one is rationalization of the denominator. So what is the concept? rationalization, rationalization, rationalization. So first of all, you should know that what do you mean by the rationalization. So how to do the rationalization? So rationalization is a process of converting a given surd into a rational number. That means multiplying a surd by another surd to get a rational number. That means we have to remove the square root symbol. That is called rationalization. Multiplying a surd by another. Multiplying a surd by another surd to obtain a rational number. Obtain a rational number is called rationalization. Rationalization, or you can say the process of multiplying a surd. You can write down that also. The process of multiplying a surd by another surd to obtain a rational number is called rationalization. Yeah. Then the surds which are multiplying together, are called rationalizing factors. In short form, it is denoted as RF. Rationalizing factor. See that rationalization is a process of multiplying a surd by another surd to obtain a rational number is called rationalization. And the surds which are multiplying together are called as rationalizing factors. That means RF. Each one is called a rationalizing factors to other one. Now, for example, root 2. Now, from which surds you should multiply this to get a rational number? That means we should remove this. So, to remove this, what we can do is, you can multiply with the same. Then, this can be written as root 4, or it is simply 2. In another way, root 2 into root 2 is root 2 whole square. Then square get cancelled. This is 2. Clear? Then, let us take another one. 3 root 5. 3 root 5. Here, the square root symbol is only for 5. So, no need of taking a coefficient. Therefore, you can take it or multiply this with the root 5 only. Even if you multiply with the 3 root 5, nothing wrong. You will get the same, means you will get the rational number. So first you should multiply this. 3 ones are 3, then root 5 whole square. I'm taken this step. Okay, now this is what? 3 into 5. Square root get cancelled. So this is 5. 3 5 is a 15. So you got the rational number. So here this 2 is the RF of this 2. Here 3 root 5, RF is root 5. So take some more example. Root 7 is root 7 whole square is 7. Root x into root x equals root x whole square. Square get cancelled, x. So from this what we can conclude is RF of monomial surd is the surd itself. So while you are writing the RF of a monomial surd, how to write the monomial surd? You should write the same surd as its RF. That means rationalizing factor. Clear? Right? Now, let us write some more examples of this. 3 root 8. 3 root 8. RF of 3 root 8. RF of 3 root 8 is root 8. So how it is? 3 root 8 into root 8, that is equal to 3 into root 8 whole square. Square gets cancelled. 3 into 8 is 24. So it is a rational number. Okay. Now after this, let us take the rationalizing factor of binomial. RF of binomial. How to take the RF of binomial? Now for this, let us take an example. Root 3 plus root 2. Now what is the RF of this? Okay, you can't take this as minus root 3 minus root 2. Okay, if you are taking like that also, you won't get the rational number. For example, if I am multiplying this with the same root 3 plus root 2, then it becomes root 3 plus root 2 whole square. Then apply the a plus b whole square formula, then it becomes root 3 whole square plus root 2 whole square plus 2 into root 3 into root 2. So square root get cancelled. 3 plus 2 plus 2 root 6. This is 5 plus 2 root 6. Here you won't eliminate the square root symbol. You have the square root symbol in the binomial. So it is not a rational number. So a rational number and irrational number, sum of a rational and irrational is irrational only. Therefore, this is not the RF of the given surd. That means for a binomial surd, if you are writing the same as the RF, then you won't get the rational number. Then how to take that? So just I am writing here root 3 plus root 2. Just change the sign of the binomial. Then you write down that 3 minus root 2. Then this is what? A plus b into a minus b. You can write this as a square minus b square. A square minus b square. Then square root cancel. you will get 3 minus 2. 3 minus 2 is 1. That is what? A rational number. Clear? So this is a what? RF of a binomial. Now the numerical coefficient is a 1. So it is a pure surd. Clear? Now if the numerical coefficient is different in the previous one, monomial surd, if the numerical coefficient is other than 1, we are not taking that to write the RF. But in the binomial surd, it is entirely different. We should take the numerical coefficient as it is. Okay. Why? Because look at this. 3 root 5 minus 2 root 3. This is a binomial surd. If you are multiplying this by changing the sign and without the numerical coefficient, then it becomes 5 plus root 3. Then you cannot write this in the form of a plus b into a minus b. Clear? So it is not in the form of a plus b into a minus b. Even the sign is there, but different. A is different, b is different. See, here is a is 3 root 5, here a is root 5. So we can't write that as a square minus b square. So remember this, to write the RF of a binomial surd, then you should consider the numerical coefficient as it is. Clear? So here you write down 3, here you write down 2. Then only it looks like a plus b. So a minus b into a plus b. First term and second terms should be the same. Then only it is following a square minus b square form. Clear? Now here this is 3 root 5 whole square minus 2 root 3 whole square. Now while you are writing the square, so you should square the numerical coefficient. 3 square is 9. Then root 5 whole square. If you want, you can write one more step. 3 square root 5 whole square minus 2 square root 3 whole square. Then this is 9 into square square cancel 5 minus 2 2s are 4, then square square cancel into 3. So 9 5s are 45 minus 4 3s are 12. So 45 minus 12 is 3. 4 minus 1 is 3. 33 is a rational number. Clear? So this is how to take the RF of a binomial surd. Clear? Now let us take one more example of a binomial surd. 8 root 7 plus 10 root 3. Now this is a binomial surd. Then RF of, or you can write RF is 8 root 7, put a sign change, 10 root 3. So this is very important in rationalizing the denominator. So how to write the RF, because it is there in the 10th standard also. So you learn here itself. Now after this you write down the product 8 root 7 plus 10 root 3 into 8 root 7 minus 10 root 3. And one thing you should remember, rationalization of the denominator, we are writing the RF of the denominator, then it is always in the form of a plus b into a minus b. Remember that. And you should write the denominator always in the form of a square minus b square form. Clear? Now here this is, you can write it as 8 root 7 whole square minus, and here is very important, you should write minus only, then 10 root 3 whole square. Then 8 square is 64 into 7. Square square get cancelled. 10 square is 100 and root 3. Sorry, 3 root cancel. You get 3 only. Now 7 fours are 28. 2. 7 6 are 42 plus 2 44 minus 300. Now this is 8 4 1 148. Here this is how to take the RF of a binomial surd. So RF of a binomial surd is the surd with the numerical coefficient as it is. Clear? Now I am showing how to rationalize the denominator. Clear? Now see that rationalization of denominator. Example, rationalize the denominator of 2 by root 3. And remember one thing, here they asked to rationalize the denominator only. So sometimes you will get the irrational number in the numerator. Okay, don't bother about the numerator. Numerator may be rational or irrational, but you should remove the irrational number, that means square root symbol in the denominator. So how to proceed this? How to do the problem? First step, you write the RF of the denominator. RF of root 3. Here denominator is root 3. So RF of root 3 is, now this is a monomial surd. Therefore the monomial surd itself is the RF. Clear? So first you should write down this. Then second step is, step 2 is multiply numerator and denominator by this RF. That means 2 by root 3 into root 3 by root 3. ಅರ್ಥ ಆಯ್ತಾ? RF ಅಂತ ಏನು ಬರ್ಕೋತೀವೋ ಆ RF ಇಂದ ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನೋಮಿನೇಟರ್ ಎರಡನ್ನೂ ಡಿವೈಡ್ ಮಾಡಬೇಕು. Now and then multiply numerator and denominator. Clear? Now 2 into root 3 is 2 root 3 by root 3 into root 3, you can write it as root 3 whole square. Then this is 2 root 3 whole divided by 3. Now square root get cancelled. So this is the way of rationalizing the denominator. Clear? Look at this. And remember this, here you should write only the rational number. Understood? Now let us take another example of monomial surd only. First question. Second question. 1 by root a. 1 by root a. Now RF of root a is root a. Then after writing that, you just multiply 1 by root a into root a by root a. That is 1 into root a is root a by root a into root a whole square. Square cancel. This is root a by a. Clear? Now let us take one more example. Rationalize the denominator of 5 by root 10. 5 by root 10. Then first you write down RF of root 10 is root 10. Then 5 by root 10 into both numerator and denominator multiplied by this. Then this is 5 root 10 by, just you write down, root 10 whole square. Square to square cancel. Then this is 5 root 10 by 10. 5 ones are 5 twos are. Then this is root 10 by 2. And remember, don't divide this 10 by 2 because it is inside the square root symbol. If you want to cancel this, then here also you should get the root 2. Okay, now this is a rationalization. Then this is the third question and this is the fourth question. What is that? Now write down 8 root 3 by 5 root 7. Now rationalize the denominator, means I am writing directly into, only should take the RF of root 7 is RF of root 7. No need of the numerical coefficient. So this is what? 8 root 3 sevens are 21 by 5 root 7 whole square. Then this is 8 root 21 by 5 into 7. Square to square root get cancelled. So this is what? 8 root 21 by 7 5s are 35. Clear? See that? So before you are writing the or doing the rationalization, first you should write down the RF of the given denominator. Clear? Now, next, rationalize the denominator of 1 by 3 plus root 2. So look at the question. 1 by 3 plus root 2. Now, first step is what? RF of 3 plus root 2 is 3 minus root 2. So look at the changes. For binomial, sir, you change the sign, middle sign only, not the first and last. Okay. Now multiply both numerator and denominator by 3 minus root 2. So 1 by 3 plus root 2 into 3 minus root 2 by 3 minus root 2. Now here 1 into 3 minus root 2 is 3 minus root 2, and I told already this denominators always in the form of a plus b into a minus b. Therefore a plus b into a minus b is what? A square minus b square. A square minus b square. So this is equal to 3 minus root 2 whole divided by, see here it is not cancelling, 3 square is 9. Here only this cancel, minus 2. So this is 3 minus root 2 by 7. 9 minus 2 is 7. This is a what? Rationalization of binomial. The denominator is the binomial, then how to rationalize the denominator. Understood? So this is how the rationalization of the denominator takes place. Clear? Now after this you have lots of problems on the rationalization of the denominator, and you have lots of problems in the reference books also. You just go through that reference books. Okay, study well, practice all the questions, because you have the application level of this rationalization of the denominator. So one thing is, these two things you should do that. One is, before starting you should write the RF of the binomial. Then by the RF multiply both numerator and denominator, both the numerator and denominator. By the RF multiply both numerator and denominator. So first step is write the RF of denominator. Second step, by the RF multiply both numerator and denominator. Third is write the denominator in the form a square minus b square, and then simplify. So this is what the steps you should follow while the rationalizing the denominator. Clear? Understood? Now go through the textbook. Textbook you don't have much more problems, but go through the reference books and do the problems. Clear?